students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing the numericals of magnetic effect of electric current. Let's take on please. When a current of 60 milliamps, is passed through a tangent galvanometer, when a current of 60 milliamps is passed through a tangent galvanometer, the deflection is 45 degrees. The deflection is 45 degrees. The tangent galvanometer has 50 turns, each of radius 8.8 centimeters. The tangent galvanometer has 50 turns, each of radius 8.8 centimeters. Find the value of the horizontal component. Find the value of the horizontal component of Earth's magnetic field. Find the value of horizontal component of Earth's magnetic field. Horizontal component of Earth's magnetic field, mu 0 Ni. This is from your tangent galvanometer, guys. 2r tan theta, right? Where mu 0 is the permittivity of free space, mu 0 is going to be equal to 4 pi into 10 raised to minus 7 SI units. N I know, I know, R and theta also. So you should be able to get the value. Straightforward multiplication. You should get this answer. The answer for this should be 2.141 into 10 raised to minus 5 Webers per meter square. Next, take on next one please. The radius of a tangent galvanometer. The radius of a tangent galvanometer of 50 turns, the radius of a tangent galvanometer of 50 turns is 7.7 centimeters. The pointer shows a deflection. The pointer shows a deflection. The pointer shows a deflection of 30 degrees. The pointer shows a deflection of 30 degrees. Find the current. Find the current if the horizontal component. Find the current if the horizontal component is 4 into 10 raised to minus 5 Webers per meter square. If the horizontal component is 4 into 10 raised to minus 5 Webers per meter square. Same formula guys. I can say BH is equal to mu 0 Ni 2r tan theta. They've asked me to find out current, so if I cross multiply, I'll get BH into 2r tan theta upon mu 0 n will give you I. We already know that mu 0 is 4 pi into 10 raised to minus 7 SI units. So in that case, you should be able to find the current. The current in this should be 56.60 into 10 raised to minus 3 amperes. That should be the current that should be flowing through the coil. Next, take down next one please. What is the magnetic induction? What is the magnetic induction at the center of a tangent galvanometer? What is the magnetic induction at the center of a tangent galvanometer of coil. What is the magnetic induction at the center of a tangent galvanometer of coil 50 turns having a radius of 10 centimeters, when a current of 0.35 amps passes through the coil. When a current of 0.35 amps passes through the coil. Also find out the deflection of the needle. If the horizontal component is 4 into 10 raised to minus 5 Webers per meter square. If the horizontal component is 4 into 10 raised to minus 5 Webers per meter square. Now they've asked you to find out the magnetic induction at the center of the coil. The magnetic induction at the center of the coil is nothing but mu 0 Ni upon 2R. Right? That's the formula for magnetic induction at the center of the coil. You know mu 0. Mu 0 can be written as 4 pi into 10 raised to minus 7 SI units. N I know, I know, R also is known to me. So in which case I should be able to get the value of magnetic induction at the center of the coil. They've also asked me to find out what will be the deflection in the coil. Now I can say for a tangent galvanometer, we know that BH is equal to mu 0 Ni upon 2R tan theta. They've asked you the deflection, therefore I can say tan theta is mu 0 Ni upon 2R into BH. Therefore you could say that theta is equal to tan inverse of mu 0 Ni upon 2R BH. You should get this answer, right? The answer for this should be the magnetic induction at the center of the coil should come out to be 11 into 10 raised to minus 5 Webers per meter square, and the angular deflection should be 70 degrees. Right? Take down next one, please. A tangent galvanometer has 500 turns of radius 2 pi centimeters if the horizontal component is 3.6 into 10 raised to minus 5 Webers per meter square. Find the reduction factor. Also find the deflection. If the current is 12 milliamps. Also find the deflection if the current is 12 milliamps. Reduction factor. For a tangent galvanometer, reduction factor K is nothing but 2r dh. This was that constant value that you had, mu 0 n, right? So reduction factor is 2r dh upon mu 0 n, where mu 0 is 4 pi into 10 raised to minus 7 SI units. So you should come to know the reduction factor. Once you know the reduction factor, then I can say that deflection for a tangent galvanometer current is reduction factor into tan theta. That's how we derive that current is directly proportional to the deflection. Thus I can say that tan theta is I upon k. Therefore the deflection theta is tan inverse of I upon k. Right? You should get this answer as K should be 7.2 into 10 raised to minus 2 ampere, and theta should be 59 degrees 2 minutes. Right? Next, take the next one please. The coil of tangent galvanometer. The coil of tangent galvanometer. The coil of tangent galvanometer has a diameter of 16 centimeters. The coil of tangent galvanometer has a diameter of 16 centimeters and a current of 0.5 amps. A current of 0.5 amps is passed through it. A current of 0.5 amps is passed through it. If the deflection of the needle, is 60 degrees, if the deflection of the needle is 60 degrees, find the length of the wire used. Find the length of the wire used if the horizontal component. Find the length of the wire used if the horizontal component is 2 into 10 raised to minus 5 Webers per meter square. I can say that for a tangent galvanometer, I is equal to 2r dh upon mu 0 n tan theta. That's your reduction factor into tan theta. Now, mu 0 we know is 4 pi into 10 raised to minus 7 SI units. Now the only unknown here, I know the radius, current, deflection, horizontal component. The only unknown is n. So when you solve this, you will get n is 2r dh upon mu 0 I tan theta. You will come to know the number of turns. Now they haven't asked you the number of turns, they've asked you to find out the length of the coil. Now the coil, if it's a coil, the length of one circle will be its circumference. So the total length of the coil will be equal to number of circles into length of one circle. Length of one circle is nothing but 2 pi r, which is the circumference. So when you multiply this, you will come to know the total length of the coil used in the tangent galvanometer. The answer for this should be 4.43 meters. Next, a current of 0.1 amps. A current of 0.1 amps produces a deflection of 30 degrees. A current of 0.1 amps produces a deflection of 30 degrees. What current will produce a deflection of 60 degrees what current will produce a deflection of 60 degrees and how much deflection will be produced by a current of of 173.2 milliamps. Right? Now, for a tangent galvanometer, I know that current is equal to K times tan theta, right? Therefore, I can say that I1 is equal to K times tan theta 1. Similarly, I can say I2 is equal to K times tan theta 2. If I divide equation 1 and 2, I'll get I1 upon I2. K gets cancelled as tan theta 1 upon tan theta 2. Out of which I know I1, I know theta 1, theta 2. I should be able to get I2. From here I should get I2. I can say also I1 upon I3 should be equal to tan theta 1 upon tan theta 3. Right? Out of which I know I1, I3, I know theta 1, I should be able to get theta 3. Right? I'll get tan theta 3 and then take tan on the other side. Tan inverse of the given number will give you theta 3. The answer for this should be I2 is 0.3 amps and theta 3 is 45 degrees. Next, take on next one please. Current passed through two tangent galvanometers. Current passed through two tangent galvanometers connected in series. The radius of the first coil is 3 times the radius of the second coil, and the number of turns in both are same. The deflection recorded in the second galvanometer is 60 degrees. The deflection recorded in the second galvanometer is 60 degrees. Find the deflection in the first galvanometer. Find the deflection in the first galvanometer. Now, for a tangent galvanometer, we know that current is equal to, or for a tangent galvanometer, I know that VH is equal to mu 0 Ni upon 2R tan theta. Therefore, I can say that current is equal to VH into 2R tan theta upon mu 0 N. Now, since the two galvanometers are connected in series, therefore same current should flow through them. I1 should be equal to I2. Since the two galvanometers are connected in series the current remains constant. That means now the horizontal component will be same, 2R1 tan theta 1 upon mu 0, permittivity will be same, upon N1 is equal to VH into 2R2 tan theta 2 upon mu 0 into, right, VH 2 gets cancelled, mu 0 gets cancelled, you will get R1 tan theta 1 upon N1 Now N1 is equal to N2, right in the beginning we've said, so N1 and N2 will also get cancelled. So in which case you will get R1 tan theta 1 is R2 tan theta 2. The radii of the two are given to you, deflection of the second coil is given to you. You should be able to get the deflection of the first coil now. The answer for this should be 30 degrees. Next, take down next sum please. A tangent galvanometer has 50 turns. A tangent galvanometer has 50 turns and radius of 10 centimeters. A tangent galvanometer has 50 turns and radius of 10 centimeters connected in series with another tangent galvanometer of 100 turns and radius 15 centimeters. The same current flows through them. Find the deflection in the second. If the deflection in the first is 45 degrees. If the deflection in the first is 45 degrees. Fine, do we get this thing clear? Now this is replica of the previous sum, I'm not even solving it. Same current is flowing through the coils. You have number of turns, radius given to you, deflection of the first coil given to you. You should easily be able to get the deflection of the second coil. Look at the previous sum and you should be able to get this answer. The answer for this sum should work out to 53 degrees 7 minutes. Next, take the next sum please. Two tangent galvanometers are same in all respects. Two tangent galvanometers are same in all respects except that one has 50 turns. And the other has 500 turns. They are connected in parallel. Find the relationship between the deflection observed. Now, since the two tangent galvanometers are same in all respects, therefore I can say that if R1 and R2 are their resistance, then R1 upon R2 should be equal to N1 upon N2. If the two tangent galvanometers are same in all respects, then the resistance of the two coils should be dependent upon the number of turns, because they are same in all the other respects. Their radii is same, permittivity is same, horizontal component is same. So in that case, I can therefore say that N1 and N2 are given to you. So you will get R1 upon R2 is 50 upon 500. So you will get 10 times R1 is equal to R2. right? Now, since they are connected in parallel, you should have same potential difference flowing through them. Since they are connected in parallel, therefore V1 should be equal to V2. The potential difference across the first should be the same as the potential difference across the other. But potential difference by Ohm's law is nothing but I1 R1 should be equal to I2 R2. Right? Also, for a tangent galvanometer, I can say that BH is equal to mu 0 Ni upon 2R tan theta. Right? So in which case I can therefore say that current is BH 2R tan theta upon mu 0 N. That means I can therefore say they are same in all respect. Mu 0 N. I can therefore say that I1 will be BH 2R tan theta upon mu 0 N1. Now, since the number of turns are different, therefore the deflection will also be different. Similarly, I can say I2 is BH 2R tan theta 2 upon mu 0 N2. Substitute in the above equation, therefore I can say that I1 R1 is equal to I2 R2. That means BH 2R tan theta 1 upon mu 0 N1 into R1 is equal to BH 2R tan theta 2 upon mu 0 N2 R2. Should get your answer now. You already know the relationship between R1 and R2. R2 can be written as 10 R1. You will get your relationship between tan theta 1 and tan theta 2. Answer is theta 1 should be equal to theta 2. Next, take on next one please. Find the current sensitivity of a tangent galvanometer. Find the current sensitivity of a tangent galvanometer when its deflection is 60 degrees, number of turns is 50, radius is 10 centimeters, and the horizontal component is 3 into 10 raised to minus 5 Webers per meter square. Now I can say that current sensitivity is d by di with respect to theta, which can be written as, we've derived this as cos square theta upon k, where k stands for reduction factor, but your reduction factor, this is nothing but cos theta upon k, but your reduction factor is nothing but 2r dh upon mu 0 n. Take this on the denominator of denominator becomes numerator, so you will get mu 0 n cos square theta upon 2r dh. That should be your current sensitivity, right? Out of which mu 0 I know is 4 pi into 10 raised to minus 7 SI units. You know n, you know theta, BH is known to you, R is known to you, you should be able to get your current sensitivity. The answer for this should be 2.618 degrees per ampere. Next sum please. a solid wire of radius 10 centimeters, a solid wire of radius 10 centimeters carries a current of 5 amps. Find the magnetic field. Find the magnetic field at a distance of 10 centimeters comma 20 centimeters away from the axis. Now, magnetic induction at a point along the axis is given by the formula mu 0 I upon 2 pi a. So, magnetic induction at a distance of 10 centimeters will be mu 0 pi upon 2 pi a1. Similarly, magnetic induction at a distance of 20 centimeters will be mu 0 I upon 2 pi a2. Again, straightforward substitution of the formula and you should get the answer. The answer for this should be B1 should come out to 10 micro Tesla and B2 should come out to 5 micro Tesla. Next, take on next one please. A long solenoid wire has 500 turns and a length of 0.5 meters. It has a flux density of 2.52 into 10 raised to minus 3 Tesla. Find the current in the solenoid. Now guys, the solenoid wire has a length of 0.5 meters and it has 500 turns. So what are the number of turns per unit length? The number of turns per unit length, N, is going to be N by L. The total number of turns divided by the length. Now, if in that case, if current I flows through the solenoid, for a solenoid, we know that magnetic induction is nothing but mu 0 Ni. What have they asked us to find out? They've asked you to find out the current through the solenoid. So I can therefore say I is B upon mu 0 N. Should be able to get this answer. B is given to U. Mu 0 is 4 into 10 raised to minus 7. And you just found out. Your answer for this should be 2.005 amps. Right, next, take on next one please. A solenoid has a length of 1.23 meters and an inner diameter of 4 meters. It has 5 layers. It has 5 layers of windings. It has 5 layers of winding of 850 turns each. It has 5 layers of windings of 850 turns each and carries a current of 5.57 amperes. What is the magnetic field at the center? What is the magnetic field at the center of the solenoid? Straightforward. First, let's find out the number of turns per unit length. Number of turns per unit length. Number of turns per unit length is total number of turns divided by length. You have 5 layers of 850 turns, so the total number of turns will be 5 into 850. Length is given to you as 1.23. Once you have this, then you can find out, you can say for a solenoid, magnetic induction is mu0 Ni. You just found out the number of turns per unit length. mu0 is a constant. Current is given to you. You should be able to get that answer. The answer for this should be 24.19 into 10 raised to minus 3 Tesla. Next, take our next one please. A coil has 300 turns. A coil has 300 turns. Its inner and outer diameter is 22 centimeters and 26 centimeters. Its inner and outer diameter are 22 and 26 centimeters. Find the magnetic induction when it carries a current. Find the magnetic induction when it carries a current of 5 amps. Now here guys, they haven't given you the length of the wire. They have given you the inner diameter and the outer diameter. First, let's find out the mean radius. Mean radius will be inner radius plus outer radius divided by 2. The two diameters are 22 and 26, so the radius will be 11 and 13 upon 2. So in that case, you will get the mean radius as 12 centimeters. 12 into 10 raised to minus 2 meters, right? Once I know the radius of the turn, then I can find out the length of the coil. The length of the coil is going to be nothing but 2 pi r. The length of the coil is going to be nothing but the circumference. Once I know L, I can find out the number of turns per unit length, that is N upon L. N I already know, right? And for a solenoid, I can say that B is equal to mu0 Ni. What have they asked you to find out? They've asked you to find out B. They've asked you to find out the magnetic induction. You should be able to get the magnetic induction from this. This should give you an answer of 0.025 Tesla. Right? This finishes this chapter. We'll stop this here for the day. Thank you very much.